Okay, this is our May 2nd, Tuesday, May 2nd, the quiz we took for you to review. If you, in the event that you need to retake this, it will be similar. So, domain, we ought to recognize 16 minus x squared under a radical. We know that it can be 0, but it can just barely be 0. Therefore, 4 is a boundary for us. So I can maybe just jot that over here on a number line. 4 is a boundary, as is negative 4. And I can put 4 here, barely. And I can put negative 4 here, barely. But I can put them, so solid dots. And 0 lies between. I try 0. Oh yeah, I can take square root of 16 minus 0. So our between is good. 5 would be a bad choice. We'd get an imaginary. Negative 5 would be a bad choice. So our domain is from negative 4 to 4. Also, hopefully upon inspection, we can note what our zeros would be of this function. What value of x would create 0? Well, if this x was 0, I'd have 3 times 0 times square root of 16 minus 0 squared, but that 0 would rule. If this was 0, in other words, if x was plus or minus 4, we'd get 0 under the radical. Square root of 0 is 0, times whatever we have out here is going to be 0. So those are our zeros, so I might put those on our graph right now. I might also, just as a note to myself, say we are confined between negative 4 and 4. And just make these little markers. My graph should exist between there. Okay, first derivative, here we go. We're going to have some fun with this. I'm going to, in order to find that first derivative, I'm going to rewrite with exponents rather than radicals. So I'm going to write f of x as 3x times 16 minus x squared to the 1/2 power and work on its derivative. Here we have a function of x times another function of x. So that is a product rule. I want the just plain first function times the derivative of the second. That is a chain. I have an inside function raised to the 1/2, so I want 1/2 the inside function to the negative 1/2, and then I need the inside derivative times negative 2x. So that is the first function times the second function's derivative. Then plus, this is the easy part, the first function's derivative, just 3, times the plain old second function. And now we're left to simplify. And to be honest, most people don't miss anything here, except perhaps sometimes we forget to take care of that inside derivative, or as we talk about in class, treat the baby function. So I'm going to go ahead first and figure out sign. I've got this, positive times positive times positive times negative times positive. That's going to be negative. I've got 3 times 1/2 times 2, or 1/2 times 2, 1 times 3, 3. And I've got a pair of x's, x squared. And then they're times this mess, 16 minus x squared to the negative 1/2. This term's pretty clean right now, plus 3 times 6 minus x squared to the 1/2. So we determine now what we can factor out. I think I'm going to factor out a negative. I might regret that, but I'm going to factor out a negative. I can certainly factor out, oh, I said x squared, but I didn't write x squared. I'll bet you guys were yelling at the computer. I can certainly factor out a 3. I can't factor out x's, but I can factor out, you're probably yelling at the computer about this one too. If I was proud, I'd restart this video, but I'm not proud. So we can factor out a 16 minus x squared, and we take out the smaller exponent. And then we are left with, from here, from this to this, I'm missing an x squared. And that's all I'm missing. So that would give me the first term. From here to here, I've got a negative, I need a positive, so I have to multiply by a negative. That would give me positive 3. And I didn't take out exactly 1/2 of these. So what gets me back to 1/2 there, if I took negative 1/2 times a full 1 factor here, that would be negative 1/2 plus 1, 1/2. Or as I've been saying, you use the bigger value minus what you took out. 1/2 minus negative 1/2, 1. So we get, I'm going to leave negative 3 in the numerator because it's to the first power, but this is to a negative power. It can go to the denominator, become positive 1/2. And inside of parentheses here, let's see, I've got an x squared, eventually plus another x squared. And I would be okay with that. You may also factor another 2 out of here, giving us negative 6 times x squared minus 8 on 16 minus x squared to the 1/2, or the square root. So our first derivative, as we just found out, could be written as negative 6 times x squared minus 8 on either the square root or 16 minus x squared to the 1/2 power. What do we normally do with that? We normally set that equal to 0. So if I set that equal to 0, the only way this fraction is going to be 0 is if x squared minus 8 is 0, and we can quickly get to plus or minus 2 root 2. Therefore, the slope is 0 at 2 root 2 and negative 2 root 2. So I likely, since I know I'm here, 0 here, 0 here, those are my only zeros, I either go up, and I don't know what I'm doing as I'm going up, and hit a peak here and come back down, or I go down and hit the very lowest point here and go back up. Same on this side. So my max and min are going to be located at negative 2 root 2 and 2 root 2. How do we know which one? Well, I could, for instance, put 1 into the original function, and I get 3 times square root of 15, which is a positive number, which means when I put 1 in, I'm up. Or I could put 0 into my derivative, and that would give me, let's see, f prime of 0, I would get positive 48. If I put in 0, square root of 16, 4, I'd get 16. Which means that's not 16, I get 12. But it's a positive, which means my graph is going up through 0. Okay, so it goes up through 0, it hits some peak, and then comes back down. It must hit some bottom value, and then come back up. Okay, so it's taking shape. All right, so therefore I have a minimum point to the left, so that's at x equals negative 2 root 2. I have a maximum point to the right at x equals 2 root 2. If we wanted to know the y value, we'd have to put that value back up in here and work through that. We're not going to do that for the purposes of this. And I know that my graph is increasing from here to here because there's no other places that it levels off. So I can't come down and then come back up because I'd have to have another level off place. So it's increasing from negative 2 root 2 over to 2 root 2. And it's decreasing from negative 4 to negative 2 root 2. And then again, so we use an OR symbol for that, a union symbol. It's decreasing again from 2 root 2 to 4. Okay, here we go. Second derivative. Toughest part of this series of 4 quizzes we're going to take is going to happen right here. So I want to find the second derivative. This is a quotient rule. There's some things going on in that quotient rule, but I want quotient rule, low function, derivative high. This negative 6 just survives. It's a coefficient, it survives, and then we take the derivative of x squared minus 8 and we get 2x. So that's low to here, d high, minus high function, that's negative 6, so plus 6x squared minus 8 times derivative low. That is 1/2 leave the inside function or the baby function alone to the negative 1/2, treat the baby, negative 2x. So that is high, d low. Okay, all of that is over the square of the thing below, and that's about the only thing I liked about this, 16 minus x squared. All right, it's algebra now. Calculus is done. Equals, I'm going to get the sign right. This times negative times positive is going to be negative. I've got a negative 12 and I've got an x. Times 16 minus x squared to the 1/2. Here I'm going to take a 6 times a 1/2 times a negative 2. That's going to be a negative. 6 times a half, 3, times the 2 back to 6, and we've got an x. And we've got an x squared minus 8. And we've got a 16 minus x squared to the negative 1/2. And all of that is on 16 minus x squared. So, once again, I factor the top. I'm going to take out a negative. Both terms are negative. This term and this big old term over here, both are negative. I'm going to take out a negative. I can factor out a 6. I can factor out an x. I also have factors of 16 minus x squared in both of these. How many do we take out? Our choice is 1/2 or negative 1/2. We take out the smaller, negative 1/2. And that leaves us with, let's see, negative 6x to become negative 12x. I need to multiply by 2. I didn't take out exactly 1/2. I took out negative 1/2. We take 1/2 minus negative 1/2. That is one of these things. I need one of these 16 minus x squareds, just to the first. That's a good problem. Then if I took out a negative 6x, this becomes plus. I did not take out x squared minus 8, but I did take out exactly that term. And all of that is to be divided by 16 minus x squared. So let's get some simplifying done here. I'm going to leave this. See, this negative exponent is this is the base of it. It's only affecting 16 minus x squared. These are both to positive powers. This stays up top. Negative 6x stays up top. This can go to the bottom as a factor, 16 minus x squared to the positive 1/2. For up top, I'm going to do my constants first. Then I might make a change on this. I get 32 minus 8, 24. I get minus 2x squared. I get plus an x squared. So that's minus an x squared. And I also, in the denominator, have one of these 16 minus x squareds. Now, I could live with that for the numerator, but because I have kind of a preponderance of negatives here, I think I'm going to pull a negative out of this and multiply it here. I'm going to change this to 6x times the x squared would become positive, the 24 would become minus. All on, how many of these 16 minus x squareds do I have? A half of them here, one of them there, one and a half of them, or 3/2. There we go. Just a whole lot of easy things to do, making it kind of tough. All right, so we just came up with 6x times x squared minus 24 on, sorry about my writing, 16 minus x squared to the 3/2 power. And if we set that equal to 0, either 6x equals 0 or x squared equals 24, so either x equals 0 or x equals plus or minus root 24. But plus or minus root 24 is just a little bit less than plus or minus 5. And plus or minus 5 are beyond our domain in both directions. Therefore, my only inflection point is where we thought it might be at x equals 0. So that means the cupping on this side is consistent, so it must always be cupping down. Meaning I wouldn't draw this like this and have a cupping up feature to it. And the cupping here must always be cupping down. Therefore, we are, cupping up, cupping down, cupping up. So therefore, we are concave up from -4 until 0, and concave down from 0 until 4. Okay, hopefully we're seeing this enough that we're able to battle through this algebra. Early results were a little lower scores than what I've seen than what I saw on the first of these, but still pretty good. I think we had about half, maybe a little bit more than half, get this on the first try. Okay, so that's what today's quiz was about. If you are clever enough before you take today's quiz to be watching my video site, maybe you're going to see today's quiz. Good luck. Let me know what I can help you with.